Well, welcome to solving multivariable systems. Now, the other day we solved systems involving x's and y's, and sure, we might have had x squareds and y squareds, but this time, instead of adding more exponents, we're adding more variables. And the technique we're just going to start out with is we just have to suck it up and do this problem. You just need to jump in and try to make it work. So it's through sheer iron will and mathematical power that we're going to solve these systems. So the first thing I do is I step back and I examine the system and I say, okay, well look, I need to get rid of a variable. It doesn't matter if I get rid of x, y, or z, doesn't matter, but I don't know, I'm just feeling like z's can cancel out pretty quickly. So if I take this blue equation and this red equation in their current states, and I just take the blue equation right there, and the red equation, I don't even have to manipulate them at all. I could just take those two equations and add them together. Look at what I get. I get 3x minus 2y. If you look, this is kind of nice. The z's cancel out. And now I just have an equation with x's and y's. That's great. That's Algebra 1 stuff. Now, I need a second equation with just x's and y's. So I got this black equation from the blue and the red. So I need to come back over here and get another equation with just x's and y's using a different combination. Like I need to bring the green in somehow. So I'm thinking maybe I can bring this green in. And what if I took this red equation, but to get rid of the z's, it looks like I need this to be not plus z, I need it to be plus 2z. So maybe I'll just multiply everything by 2. And that gives me this 2x minus 6y plus 2z equals 8. And now if I add those equations together, I get this black equation. So I have this black equation, just x's and y's, this black equation here, just x's and y's. Let's solve that. And we can solve it a bunch of different ways. I don't know, I'm thinking maybe I can just let this equation stay as is, 5x minus 22y equals negative 2. Maybe this equation, I'm thinking it might be easy to get rid of the y's. To get rid of the y's, I want this to not be a negative 2. I want it to be a positive 22. So I'll just multiply it by negative 11. And when I do that, what's it give me? It gives me this. And now when I add those two equations together, I get my y's to disappear. Nice. So the y's are gone. And I can finally, after all this work, get my x. And I get x is 4. Whew. So now that I have x is 4, I can take that and I can make a substitution like there, and I can get my y. So now I can say, okay, x is 4. So this is 12 minus 2y equals 10, and I'm going to do a lot of math in my head here because I'm super smart, and I'm going to get y equals 1. And now that I have x and y, I can plug them in, say, to this equation. I can plug in an x there, a y there, and I can solve for z. So when you're all done, we write our answer as an ordered triple. We follow the alphabet. X is 4, y is 1, z is 3. And I'm not saying this is easy by any means, but I'm saying that we just have to attack it using brute force. Unless there turns out to be a different way that might be easier. Well, stay tuned. Maybe on another day, maybe we might find an easier way. But right now, it just takes brute force and it takes patience. And when you have your homework tonight, I'm going to give you all the answers to that homework. So when you do a problem, obviously you have to show work, but you can check your answer. And if you get it wrong, you're going to have to go back in and find your mistake. And sometimes it's easy to make the same mistake multiple times. So I kind of suggest to kids, if you can't find the mistake within 5 minutes, just redo the entire thing. But let's see how you do with the problem. I'm going to go ahead and give you this one right here. I want you to solve this system. I'm going to give you the answer. Here's the answer. It's a great hint, by the way. So pause the video, try to solve that system. See if you get that answer. And if you do, you're awesome. If you don't, do it again. You can do it. It just takes some brute force to make it happen. Okay, welcome back. Hopefully you paused it and you tried it. Now I want to take a look at another system, this one here, but don't pause the video. This one is actually a little tricky. I went ahead and I solved this, and what I did is I combined these first two equations to get rid of the x's, and I got this purple equation. And then I combined the blue and the green, and I got this, I don't know, aquamarine equation. But see, that gave me a bunch of questions. Look at these question marks. Because when I tried to solve this system for z by getting rid of the y's, I ended up getting something that seemed ridiculous. I ended up multiplying through this by a -1, and it gave me those canceled, and those, so I got 0 equals 1. And 0 doesn't equal 1. And so we ran into an issue with this. And I want to kind of explain what's happening here. Now remember, when we deal with x's and y's, we know graphically that's a line. And last year in Algebra 2, you learned that when you bring in a new axis, the z-axis, that when you graph this, it's no longer a line, but it's a plane. So let's take a look at what's going on in this particular instance. So in this particular instance, here's what we have. When you solve a system of 3 variables and 3 unknowns, you can get 3 different results. The first is those 3 planes, not lines, but planes, can intersect at a single point, and that gives you a unique ordered triple. That's what happened in our example. So we had 3 planes. Look at that. What a visual. We had 3 planes meet, this blue, this yellow, and this red. And they all met at that point right there, and it gave us one unique ordered triple. But what could also happen is those 3 planes could meet, but not at a single point, but they could meet at a line. And there's a really clever way mathematicians have of explaining the equation of that line. But we're not going to learn about that this year. That would be a great college linear algebra course. But we won't encounter that this year. But there is a third thing that can happen, and this is what just happened to us in that example. The third thing is that the planes could actually have no points in common. And if that happens, you get something bizarre like 0 equals 1 or 5 equals -13. The variables disappear, and what you're left with is just silliness. And that answer would be the empty set. And it could be one of 3 scenarios. You could have 3 planes and 2 of them meet, but they all don't meet at the same spot. And it might look like that, or it might look like that, or the 3 planes could be entirely parallel. But those are the results of what could happen. And that's what happened here, is we got an empty set. Those planes don't all meet at a single point. So let's step up our game here and take a look at some word problems. So let's say that you have a quadratic equation, so a parabola, y equals something x squared plus something times x plus something. And I give you 3 points that this graph passes through. And I ask you to go ahead and come up with what A, B, and C are. I want you to find the equation that passes through these points, and it's a parabola. Well, last year you probably played around with that quite a bit, but here's what I'd suggest. We have this general form, y equals ax squared plus bx plus c. And we also have some values of x and their corresponding y values. So what I think we ought to do is take this y value right here and its corresponding x value. When y is -4, I know x is -1, and you could just substitute it right in. I can take this x value of 0, and I can put it into my general equation up here for x. I could put its corresponding y there. I could do the same for this 3, and if you do that, you get 3 equations. 1, 2, 3. 3 unknowns, A, B, C. And you can solve it. And I'll walk through the solving of this for you. You might want to pause and try it on your own, but here's how we would find A, B, and C. I'm going to go ahead and just do the math and clean up these equations. And so there's the first, and here's the and here's the third. Notice, by the way, that C is 1, so everywhere I see a C, I can now put a 1 in its place. And that's what I did down over here. I rewrote this first equation as A minus B plus 1, and there's the second equation. Now I'm going to clean those two equations up. So I came over here and I kept the A and the B on the left side, and I moved the constant to the right. And then I'm going to come over here and notice, by the way, I could divide the bottom equation by 3. These are all multiples of 3. So I'll keep the top equation the same, and I'll divide the bottom by 3. And now at the end of this problem, I can just add these two equations together, and I get 4A equals negative 8. And that means that A equals negative 2. Whoo, doggy. So I have A. I can substitute it here and find B. I already have C, and I can go back and I can rewrite this equation right here by replacing A, B, and C. Well, let's do one more problem, and I'm going to let you pause this and read this, and then we'll come back and we'll talk about it. So pause it and read it now. Well, welcome back. So what we've got here is we've got this famous turkey bowl. Of course, you all know who is going to win that. But here's the question. How many touchdowns, how many extra points, and how many field goals were made? And you probably could reason this out. You kids are smart. But let's see if we could figure it out using a system of equations. And I think when you have a word problem, one of the most important things you can start out with is defining your unknowns. And I want to know how many touchdowns, extra points, and field goals were made. So I'm going to let T equal the number of touchdowns. E is the number of extra points, and F is the number of field goals. Now, first off, I know that there were 42 points. So I can say 6 points for a touchdown, 1 point for an extra point, and whoops, I had a little typo, 3 points for a field goal. And those 3 things right there add up to give me 42 points. So this first equation, equation number 1, is just based off pure points. Now, I need a second equation, and that's going to be this blue equation. There was 1 more field goal than there was a touchdown. Now, this says the number of field goals is the same as the number of touchdowns, and that's not what this says. I know there's 1 more field goal than there is a touchdown. So do I add 1 to the left side or do I add 1 to the right side? And this always throws kids off. So I want you to think of it this way. Which are there more? Are there more field goals or more touchdowns? And the answer is there's more field goals. So to make the field goals equal to the touchdowns, we need to add 1 to the touchdowns. And think about this last statement here. There was 1 more touchdown than there were extra points. So again, if we have touchdowns equal to extra points, where do we have to add 1? And it's there. So those are your 3 equations, and you can take it from there and you can solve it to get the answer. And I will say the answer is there were 4 touchdowns, there were 3 extra points, and there were 5 field goals. So tonight you're just doing brute force, and I know this can be tough and it can be frustrating, but your homework has all the answers included, so check those answers as you go through. If you can't get it, you can always come back into the Google Meet and talk with me and show me your work, and maybe I can find where your mistake was. But just do the homework tonight, try your brute force, and maybe we'll learn another way of handling this. Maybe. Have a good day.